Hello friends, today we will go through the design of sewer section, and for the design of sewer section we need to calculate the velocity and discharge of flow in the corresponding sewer pipes. So we will deal out how to determine the velocity and discharge in the subsequent sewers. Now our problem is calculate the velocity and discharge of flow in a sewer of circular section that is running half full, having its diameter of 1.5 meters, laid at a gradient 1 in 500. Use Manning coefficient n as 0.012. The given problem comprises of the sewer running half full, and the sewer is laid at a gradient of 1 in 500 with its diameter 1.5 meters. And we are asked to use the coefficient of Manning's coefficient as 0.012. Now we shall determine the velocity and corresponding discharge in the sewer. Now friends, for the sewer running half full of diameter d, then we can write the area of such a sewer area A equals to pi d square by 8. Isn't it? Since the area of the sewer running full is pi d square by 4, so half full will be pi d square by 8, and the parameter of such a sewer P can be easily find out as pi d by 2. Now the hydraulic radius R can be easily written as R equals to A by P, and if we substitute the values of A and P, pi d square by 8 divided by pi d by 2, then we will get the radius of hydraulic radius of such a circular sewer as d by 4. So d by 4 will be the hydraulic radius of sewer running half full. Likewise, if the case is given as the sewer is running full, then again we can easily find out the hydraulic radius pi d square by 4 divided by pi d. So again the hydraulic radius in the case of sewer running full shall come out to be pi d by 4. Again pi d by 4 will be the hydraulic radius of the sewer running full. So for the half full also the hydraulic radius shall be d by 4. Now we shall use the Manning's formula for the determination of velocity and discharge. So from the Manning's formula we can easily write V equals to 1 by n is Manning coefficient into R 2 by 3 into gradient 1 by 2. So if we just substitute the values of 1 by n as 0.012 and the hydraulic radius is d by 4, d is given as 1.5 divided by 4 power 2/3 into the gradient is 1 by 500, isn't it? So 1 by 500 to the power half. So if we solve this, the value of velocity in the case of a circular sewer running half full come out to be 1.938 meter per second. So this is the amount of velocity that is passing in such a circular sewer running half full. Likewise, discharge can be given as by the continuity equation, discharge Q equals to A into P. The area of this circular sewer running half full is A is pi d square by 8, and the velocity is recently found as 1.938. So if you just substitute the values of diameter as 1.5, and if you solve this, the value of discharge in the sewer running half full comes out to be 1.712 cubic meter per second.